Hello there, Khalid Al Malawani here. Today we're going to talk about the Arduino's library, the free RTOS. But before we get started here, let's actually talk what an RTOS is. So RTOS is an acronym which stands for Real-Time Operating System. So usually when you work with any code here, at least in Arduino, it goes through a loop. So if you remember, Arduino has a void setup function, which only runs once, and a void loop function. The idea in the void loop function here is that you have certain commands, and they always run in order every single loop. Now, the commands could get more extensive, and it could develop into harder codes, but that is the general idea. In RTOS, it is handled differently. In RTOS, what happens is you have a scheduler. The scheduler here is assigned several tasks of different priorities. Note that you can make them the same priority level, and we will talk about that later. But in here, so you have task 1, task 2 here, and task 3. And every task on its own is its own loop. Okay? So what does that allow you to do? That means what this allows you to do is you can have multiple events happening at the same time. So let's say one task, for example, will be turning an LED on and off every 3 seconds. And then another task will be receiving communication from, let's say, Wi-Fi. And maybe a third task will just be move around and detect objects. Okay. If this was implemented in a simple loop function here, it would actually be harder to implement. And that is because what the void loop will allow you to do will not allow you to separate it into tasks. So if you try and set up the task here to end every 3 seconds, for example, the void loop here will not be able to time it accordingly because every function before it has to occur first. So the schedule is a pretty powerful tool. Now, the idea of the free RTOS. So the idea of the free RTOS is a operating system. So you have to understand that when you use the free RTOS library in the Arduino environment, you're actually using a different library. Instead of using the normal Arduino functionalities, you're actually developing into a real-time operating system. And there's various terms that you should be aware of. So a few of the terms you should be aware of here is, first of all, the types, different types of operating systems, or sorry, the RTOS systems you can have. The first type you can have will be a hard time. Another one will be a soft time. And the last one will be a firm time. So what's the difference between all three? So a hard time here is a hard time. Every task has to be executed at the time given. So in other words, that everything, there can be no lag or stuff cannot happen sooner than it's scheduled or things cannot happen later than it's scheduled. Everything is built to fit exactly how it is. Now, you would usually build a system like this for systems that are extremely time sensitive. Maybe nuclear powers, aircraft, all of these would be built in hard time. Soft time, on the other hand, is what it tries to do is it tries and reaches for speed. So if there's a few errors in terms of time lagging, like a task goes quicker than the other, it's not a big deal. It's severe, but it's not fatal, as in compared to a hard time, for example. So a soft time tries and achieves the quickest way to implement a design. Firm time here is basically something in between. So it's not too soft. It's not achieving the most speed, but it's not. It, things should happen in time most of the time, but it's not completely strict as in hard time. So those are the first few terms here that you should be aware of. Now, there's a few more terms that you should be aware of. The first term we can talk about here is task. And then we can also talk about scheduler. So task here is anything, is pretty much the piece of code that you're running. So as I mentioned, if you remember from my previous drawing here, task is just what you are basically what you're trying to implement. What is the code you're trying to implement, what you're trying to do. Scheduler is the overarching system that controls all of this. So the scheduler, because it is the overarching piece and it should be called first, this is developed in the void setup function, as you will see in a few minutes here, and task is developed in their own function. Okay. And then there is two different types of policies you should of RTOS policies you should be aware of. There's actually a couple more than two, but the two important ones that you should be aware of are as follows. So the first one we have preemptive scheduling, and it is written as such. And the second one will be a priority-based preemptive scheduling. Okay. So the preemptive scheduling occurs when the tasks are all given the same priority level. So all the tasks are treated as the same priority. In other words, every task is no task is more important than the other. They're all equally as important, and as such, the schedule will divide every single task to take about the same time, just to make sure that they can all proceed, they can all complete their tasks in the certain amount of time. The time defined is, just to give you a few more details, is defined by the clock period, which I'll give a brief talk about it right now. But if you want to know more, you can look into. There's a lot more resources, and I'll show you. I'll provide you with two resources at the end of this video here that you can look into. However, within a certain time period, within a certain clock period, there's only a certain known amount of time here. Okay, so what the preemptive scheduling does is, let's say you have three tasks. All three tasks here take about the exact same time. So none is basically they all take at the same time. So none is a higher priority. Priority based here is slightly different, and as you can probably guess from the name, the highest priority gets the most amount of time, and that ensures that the highest priority task has enough time to complete what it has to do. So it really depends on what you're trying to design here, and so whatever you're designing, you have to look into which system you want to implement. But these are the few terms you're going to encounter here. There's a few more terms that you could look into, but these will definitely get you started. Now let's get to our Arduino. So if I share my screen here to the new sketch here, you will see here that this is a new sketch. There's nothing implemented yet. The first thing you should do is, of course, download the FreeRTOS library. So we'll go under Tools here, and then we're going to find Manage Library. We can select that. And then the normal screen here should pop up where you will see the library manager. In your search here, you can search for FreeRTOS. Let me just show you that again. So we can go free RTOS here and just press enter. Give it a second here. And you'll see the first one by Richard Berry is the one we want. I can actually update it while we're at it, but you will see a button that says install. And we are ready to go. So I can do here is I can close that. And first thing we need to do is, of course, call the library. And we can just do that by typing hashtag include Arduino underscore FreeRTOS. Okay. Oh, and just don't forget to add the .h here. So, and we can verify just to make sure that everything is correct. As usual, we need to save first. And let's call this test RTOS. Here we go. And it's just compiling sketch at the bottom here. Okay. So let's just change the board. So in this case here, we need to, the FreeRTOS library will work on AVR boards. So whether you have an Uno or a Mega, that should work. In this case here, I had a Nano 33 IoT, which is, the FreeRTOS does not work in that board. If you do want to use an RTOS on that board, you will have to look into another library, and we can talk about that later if we have time. So in this case here, let's select the Uno and verify it. And we are done here. So first thing you need to keep in mind and always remember, in RTOS, we do not use the void loop. If you recall, the void loop is only used in the normal Arduino function, but you have to recall, if you remember from other tutorials, the void loop has to exist for any Arduino sketch. So we can just add a comment here that says so we can say that void loop will be empty as it is not necessary for RTOS operation. And we can now start developing our RTOS. First thing first, I'd like to first get started with the backbone of your task. In other words, we create our at least our task name. So in this case here, we have our first task. Let's call it task LED. And it has no arguments, and we can close it as such. And then we can have another task and call it void task movement. Empty as well, and keep it that way. So in this case here, I set up 2 tasks, at least for this. So this looks simple so far, but there's a few more things we need to add. So first of all, inside your brackets here, inside your tasks, you should add a void pointer. And the void pointer is called PV parameters. Now, you can pretty much call the void pointer anything you want, but the proper convention, and you will see if you plan to look for, if you have any issues, you probably look online. Void PV parameter is usually what they have now, but keep in mind that in most of your application, you'll never need the void pointer. Just a quick talk about void pointer here. That just means it can accept any type of pointer. It can, because it's a void pointer, it means it can accept any type, whether it's integer, float, it can accept anything, but you won't need it and you won't use it. Recall inside, if you remember from diagram at the beginning of the YouTube video of the video here, we talked about how the task is its own loop. So we always have a function here called a while one. So while one loop just means it's a loop that never ends. And that will be the same case for anything inside the function. So just like void setup and void loop in normal Arduino, in a while inside a task, it's the same idea. Anything that you want in a setup will be written prior to the loop, and anything that you need that will be inside void loop originally in an Arduino sketch or the Arduino normal operating system will actually be inside the while one. Okay, so here we have a simple backbone structure for our tasks. Now, what we need to do here is we need to tell our code here that the tasks we did create the task. And there is commands, simple commands for that we can look into. And as such, that will be the X task create. So the X task create is, as you see on the screen here, it is a fairly long function here, but this is the idea of the task create. So first of all, we have something, it's a task function variable, and it's is task function underscore t, and it's called the PV task code. So this is simply, it looks like a complicated name, but this is simply a pointer to your task function. So in other words, the name of your function. The constant character pointer constant name is what other, so it's just a pretty much a word. It's not used by the FreeRTOS, it's only for debugging purposes, but you need to include it as part of the function call here. And usually the common convention is just keep the same name as the function. The US stack depth, now it's not actually US, it's microseconds, but of course the micro symbol can now be drawn in text. And that is pretty much you're saying how much space is this function going to take in memory. Now it's a pretty heavy concept here, but the general idea you should be aware of is pretty much use the common number 128. Now, if that is not enough, and in many cases that will never happen, but let's say your code is too long, then 128 will not be enough, then you will see an error. If you actually want to determine the exact number for it, I'll give that command in a second here, what you can do to determine the exact number for that parameter. The void pointer PV parameter. So this is pretty much what the, it's a pointer to anything. You do not need also to understand that in details. What you should be aware of is usually we send nothing. So we just type it as null. Now, the important thing here is the priority, the UX priority. This is pretty much what determines the priority. So in this case here, let's say the priority of the task LED will be 1. Of course, you start with 1 being the top priority, and anything after 1 is less in priority. So this is just keep that in mind. And finally, PX created task. Once again, this is a task function pointer. You do not need to understand in details. All you need to know is that it is usually null. Now we did that for the first one here. Let's do the same thing for the second command we have, or the second task we have, and that is task movement. And once again, we have the pointer to the function, which is just the function name, and then we have task movement, which is only for debugger purposes. Keep the default number of 128 will be a null. In this case here, let's say we use a preemptive policy scheduling, and let's keep it the same priority. And once again, null. And like that, we have our first 2 tasks created. So after we do that, let's just once again verify just to make sure that everything is correct. And it does save your code as well. And it seems like there's no issues, so that's a good thing. Now, right now, we just told the schedule that we have 2 tasks for you. We have task LED and task movement. But we never told the schedule to start. So there is a simple function for that. So after you're done your setup, which is basically creating your task, what is the last line usually for before you know to tell the code that you're going to start will be something known as the v task start scheduler. And it is a simple function here or API as such. So v task start scheduler. While we're at it, also let's initialize the serial communication at 9600 baud rate. And here we have serial communication, our two tasks, and a v task start scheduler. Once again, the void loop is not used. Now, what we can actually have here, we actually, for the sake of this tutorial here, let's actually change this a bit. Let's call this task LED1 and task LED2. And as such, we need to change these names as well. So what I'm going to do here for this tutorial is we're going to light two different LEDs at two different time periods. Okay, so first thing we need to do is tell the Arduino that we have an LED at a certain place. So we remember the function for that is pin mode. Let's say the LED at the first input here will be at pin 2, or let's say yeah, 2 is fine. And then this is for sure will be output. Same thing for this one here, the LED in that certain task here we're referring to will be, let's say, at 4 and will also be output. Now in FreeRTOS, your normal coding capabilities do work. So we could also have a global variable here and say LED pin 1 is equal to 2. And of course, that's in int. And then we can say the same thing here, that LED pin 2, 4, and just put these for here. And it will work as well. And hashtag define will also work as well. So here we do, or here we have it. We have our task, their setup function is done. Now we'll need to edit their while loop. So in this case here, let's say digital right, pretty much turn the LED on every, let's say, or sorry, let's say we want to digital right LED pin 1 high, and then we will delay. Now this is important. In your task scheduler, you cannot use the delay function. Now, a quick fact about the delay here, the delay function, when you use the delay function, you actually stop the whole CPU. So you don't allow the CPU to do anything anymore. Okay, so it stops completely. But but in this case here, we don't want it to stop, right? Because if we do make the CPU stop, that means the scheduler also stopped. Because remember, the CPU is what controls the whole thing. So there's a certain function here known as vtask delay. And what vtask delay allows you to do is it allows you to delay without actually stopping the schedule. How it actually works is it delays for 1 microsecond, and then it keeps running the function. And then it stays in the while loop for whatever the amount of time you're given here, or actually it's known as the ticks, which I will talk about in just a few seconds here. But it just waits till a certain amount of ticks has proceeded. After that, it resumes your task. So never use the delay function. Okay. In this case here, the vtask delay, as I mentioned here, is in ticks. There's an easy formula here where we can change it into microseconds. And let's say I want 200 microseconds. So in this case here, what this does is you divide 200, which is in this case here, um, wait for 200 microseconds. It would change the tick value, which is unnecessary to know for our coding purposes, into milliseconds. And in this case here, I can specify the number using just at the beginning here. And then of course, we can go digital right LED pin 1 again and turn it off. And then once again, let's wait for 200 microseconds. Okay, now let's copy this code here and put it in our function here. And in this case here, we're talking about LED pin 2. And let's change this to 600 microseconds. Okay, now for the purpose of demonstration here, if you have this connected to your Arduino, you can see that this will work. And but also which I will show you in the demonstration here, but also to show you on the screen, let's also add serial command. So let's say at serial print here, we can say that LED 1 and go serial dot print line, new line, and we can say hi or on, and then here we can say it is off, and just make sure that the code is running smoothly. So let's do this like that. And then we can go here as well and do the same thing on. And of course, this will be off. And if we upload the code here, oh, okay, so it seems like there's an issue. Let me just double check here. Yeah, the port has not been defined. Common mistake here. And the code is working. If I bring this to the camera here, you will see that the red and green LEDs are lighting up at different frequencies, where the red LEDs LED1 and the green LEDs LED2. So the FreeRTOS here is working. And just for the sake of visualization here, we can open the serial monitor and make sure that this is at the proper baud rate. And you can see that it is not the most clear when it's text, but it is going at different frequencies as well. As you can see, sometimes you see more offs, because two of them are overlapping, and you might occasionally see more ons as well. So I just disconnected the Arduino here. So this is the first tutorial or the first video for the FreeRTOS here. The next video will be demonstrating how you can the proper way to communicate between the different tasks using something known as queues. But however, you can use the information provided here to get started on your own FreeRTOS project. This will be sufficient. But I do recommend that you watch the queues video as it is necessary in many cases that you will communicate between different tasks. So thank you and have fun on your Arduino adventure.